Hello, welcome you to the presentation on identifying super spreader in complex network without influence overlap. Myself, Dr. Giridhar Maji, Academic Editor Plus One, and this work is done during my PhD under the guidance of Dr. Shom Hussain, Assistant Professor, A.K. Chaudhary School of IT, University of Calcutta. This work is all about complex network and identifying the importance of nodes, and then finally the ranking their nodes based on the importance or centrality of the node in a network. So this kind of problem can be divided into two parts. For in the first part, we can identify the single node, that is the most important node, and in the another part we can identify a set of nodes that create a maximized influence throughout the network. In case of viral marketing, suppose we want to have some limited number of free sample of a new product and we want to give it to the customers or the users, then we need to identify the users whom we can give, and through the word of mouth the influence reaches to a maximum portion of the network, maximum people know about it. So that kind of situation can be handled in case of when we consider it as an influence maximization problem, and we have to identify, instead of only a single person, we have to identify a multiple set of person. We call it seed nodes in a network. So whenever we model a problem as a network, then we have to employ the network analysis like centrality matrix or centrality algorithms to find the influence. So in this work we have proposed some heuristic template based centrality measure, where we have used multiple classical centrality metrics like the degree, betweenness, closeness, and KSL, etc., to provide a template. So we have provided a template. The template looks like this: x, y, v, y is equal to degree of v into degree divided by distance. That's sum over the R hop neighborhood. Now this template can be, we have shown two variants. One is where this y denotes the K cell, and one is y denotes the M cell, that is from the mixed degree decomposition. So when the K cell version, we replace this Ky by K cell index of the node V, then multiply by this degree divided by distance and sum it over the R hop neighborhood. Then we get a measure for the node V. So in a similar way, in this case we get a measure of node V based on the M cell index. So in both cases we get a measure, a value for each node in the network through this formulation. Once we get that, then we do a iterative version, like in this case through the direct neighborhood. For each neighborhood, for each node we have a score, and now for a concerned node we consider all its direct neighbors and add the values, the scores we have already obtained, like this score, then sum it up, then to get the final score of the node. In this way we will have the final score for all the nodes, and based on that final score we can rank the nodes, like we can sort the nodes. Then the node come in the top will be the most influential user. Now for the second part of the problem, where we have to identify a certain number of nodes from the list, then the most naive way will be, if we have to identify the top three nodes from this network, suppose, then we can do what we can do, take the top three nodes, but that will not create, or that will not give the effect of maximum influence. So for that, what we have done, we have enforced some minimum distance criteria. Instead of choosing v1, v2, v3, we are choosing v1, then ignoring v2, v3, v4, then choosing v5, ignoring v6 and v7, then choosing v8. So this top three node is, the nodes are diversified throughout the network, that will create a maximum influence. So in this way we have proposed this also minimum distance criteria to get a maximum influence. So this is the very brief description of the work. So for the details you can see the paper. Thank you for listening.